This discovery could change everything. Scientists believed we understood the early universe, that galaxies took time to form, that the cosmos grew gradually after the Big Bang. But the James Webb Space Telescope is rewriting that story. It has spotted galaxies so massive, so bright, and so fully formed that they shouldn't even exist yet. One of them, nicknamed MOM-Z14, shines in a time when the universe was only 2% of its current age. Imagine seeing a fully grown city appear in a newborn world. That's what MOM-Z14 is to cosmology. This isn't just an early galaxy. This is a challenge to everything we thought we knew about how the universe evolved. And now, with the sharpest images of the infant cosmos ever taken, astronomers are seeing patterns and anomalies that hint at a universe far stranger, far older, and far more complex than the Big Bang model allows. In this video, we'll explore exactly what James Webb discovered, why it could change everything, and how these cosmic clues might rewrite the very story of the universe, from its first moments to the hidden chapters that may have come before. $13.8 billion years ago, there was nothing, no space, no time, no stars. Not even the emptiness we know as the void existed. Only a singularity, an unimaginable point, smaller than an atom, containing within it the totality of everything that would ever exist. All the galaxies, all the stars, every particle of matter and every speck of light, compressed into a single, infinite density. And then, in less than the blink of an eye, it happened, the Big Bang. Space itself began to stretch, time ignited, and the first particles of matter burst into existence. Imagine the universe as a cosmic symphony, with every note forming simultaneously in a chaotic, blazing growth. In an instant, the universe expanded faster than light in an event scientists call cosmic inflation. Reality stretched like a balloon being blown up at impossible speed, laying down the blueprint for galaxies, stars, and planets yet to come. Energy, matter, and the laws of physics intertwined in ways that still baffle even the most brilliant minds. For hundreds of thousands of years, the universe was an opaque, boiling fog of particles and radiation. Light itself could not travel freely, trapped in a dense, searing plasma. But after about 380,000 years, something extraordinary happened. The universe cooled enough for atoms to form, and the fog lifted. For the first time, light could stream across space, the first cosmic sunrise, a glow that would eventually travel billions of years to reach us as the cosmic microwave background. This faint afterglow became the cornerstone of modern cosmology, a relic of the universe's earliest moments. Scientists mapped it, studied it, and built the Big Bang model from it. But the deeper we looked, the more anomalies emerged. Tiny ripples in that ancient light hinted at forces, structures, and events the standard model could not explain. The universe, it seemed, was already whispering secrets we were only beginning to hear. In the 1960s, two radio engineers stumbled upon something extraordinary, a faint, ghostly glow coming from every corner of the sky. It was the afterglow of the Big Bang itself, the first light ever released by the universe. Scientists called it the cosmic microwave background, or CMB, a snapshot of the cosmos when it was still a baby, only 380,000 years old. This light wasn't uniform. Embedded within it were tiny ripples, fluctuations in temperature and density, subtle fingerprints left by the primordial chaos of creation. Those ripples would eventually grow into galaxies, clusters, and the vast cosmic web we see today, the very scaffolding of the universe. In a sense, it was a blueprint written in light, etched across the cosmos billions of years before any star or planet even existed. Fast forward to 2025, the Atacama Cosmology Telescope has given us the sharpest image of this ancient light ever captured, 5 times more detailed than ever before. Every pixel tells a story. Every wave pattern hints at the physical processes that shaped the cosmos at its earliest moment. For the first time, we can study the universe as an infant in unprecedented detail. But here's the puzzle: the baby universe appears stranger than we expected. The ripples aren't entirely following the patterns predicted by our theories. Some density fluctuations are too large, structures appear where none should exist, and the distribution of energy seems to defy conventional physics. It's as if the universe, even in its first moments, was already breaking the rules we thought it had to follow. These subtle anomalies are more than just curiosities. They are whispers of a deeper, hidden story. A story that suggests the universe may have begun not with a simple, uniform explosion, but with a complexity we are only beginning to understand. Launched in 2021, the James Webb Space Telescope became humanity's most powerful window into the distant cosmos, a time machine capable of capturing light that has traveled for billions of years. For the first time, we could see galaxies as they were just hundreds of millions of years after the Big Bang, when the universe was a mere fraction of its current age. And what it found stunned scientists around the world. Among the earliest galaxies was one that quickly became famous, MOM-Z14. Appearing just 280 million years after the Big Bang, it was fully formed, massive, and brimming with stars. Imagine walking into a newborn world and finding a fully grown tree that has lived for centuries, a structure that should not exist, according to every calculation we have. The existence of MOM-Z14 forces us to confront a profound question. How could galaxies assemble so quickly in the infant universe? The physics we thought governed cosmic evolution seems to falter at the very beginning of time. The universe, it appears, was already far more complex, far more efficient, and far more astonishing than we could have imagined. And then came the Big Ring. A structure so vast it challenges our sense of cosmic scale. A colossal loop of galaxies stretching 1.3 billion light-years across space, perfectly shaped and seemingly intentional. According to our models, the universe should look roughly the same in every direction on large scales, yet here was an anomaly that refused to fit. It was a cosmic fingerprint, a clue that the universe's story is far stranger and more intricate than we ever dreamed. Together, these discoveries do more than surprise astronomers, they rewrite the rules. The universe is revealing secrets that force us to rethink its earliest chapters, its structure, and even the nature of reality itself. But what if the Big Bang wasn't the beginning at all? What could have come before it, if before even has meaning in the first place? For decades, these questions were dismissed as speculative, fringe ideas. Today, they are gaining serious attention, and the implications are staggering. Sir Roger Penrose, one of the most brilliant minds in physics, proposes a vision called conformal cyclic cosmology. In his model, our universe is not a one-time explosion, but part of an endless cycle. One universe expands, cools, and fades into a cold, empty nothingness, and from that silence, a new Big Bang ignites. Like a cosmic phoenix, universes rise, fall, and rise again, each leaving subtle traces imprinted on the next. Other theories suggest that creation wasn't a single, explosive moment but a series of bursts, what some call mini-bangs. Each burst would inject energy and matter into the cosmos, building structures over time like notes in a grand cosmic symphony. This could even explain some of the universe's greatest mysteries, like the nature of dark matter and dark energy. Then there's the Big Bounce, a vision even more radical. Imagine that our universe did not emerge from nothing, but from the collapse of a previous cosmos. In this view, the universe breathes like a heartbeat, expansion, collapse, rebirth, a rhythm that has been repeating for eternity. If even one of these ideas is true, the Big Bang was not the start of everything. It was not the opening chapter of the universe's story, but a doorway, a threshold into a far older, far stranger reality than we ever imagined. And standing at that threshold, we are just beginning to glimpse the cosmic secrets that lie beyond. These discoveries do more than rewrite physics textbooks, they force us to confront our place in the cosmos. We are not just observers of the universe, we are participants in a story that may stretch far beyond our comprehension. Are we a fleeting flicker in an eternal cycle of creation, a single heartbeat in an infinite cosmic rhythm? Or are we part of a pattern, a recurring note in a symphony that has been playing long before we existed and will continue long after we are gone? The universe may not be a single, linear story that begins and ends with the Big Bang. It could be a living, breathing entity, a cycle of birth, death, and rebirth on scales so vast that human imagination struggles to grasp them. Every galaxy, every star, every particle of matter could be a part of this eternal pattern, woven into the fabric of time itself. And in this view, our own existence takes on a new perspective. We are not isolated, not incidental. We are fragments of a grand cosmic story, fleeting witnesses to its most recent chapter. The universe may be infinite in both time and possibility, and we are only beginning to understand our place within its endless rhythm. Perhaps the cosmos is not a silent, lifeless expanse. Perhaps it is alive in ways we cannot yet measure, resonating with cycles of creation and destruction, of emergence and dissolution. And in recognizing this, we find that our search for knowledge is not just about understanding the stars, it is about discovering ourselves in the infinite story of existence. Every new observation, every cosmic anomaly, every galaxy that appears too early, too massive, or too perfectly formed, is like a clue left by the universe itself, nudging us toward a truth far greater than we've imagined. Each discovery stretches the limits of our understanding, challenging the assumptions we built our models on for decades. Perhaps the Big Bang was not the beginning, not the ultimate origin, but a doorway, the threshold to a hidden history, a story older, stranger, and far more intricate than we ever dared to conceive. The universe is revealing itself in fragments, hints scattered across space and time, urging us to read between the lines. And just as we begin to grasp one mystery, the cosmos throws another before us. Galaxies forming impossibly early, colossal structures spanning billions of light years, patterns that suggest rhythms beyond our comprehension. It's as if the universe is whispering secrets from the very edge of reality. This is not the end of the story. Far from it. The narrative of the cosmos is just beginning, and every telescope, every observation, every experiment peels back another layer of its grand design. And when the next revelation comes, whether from the James Webb, the Atacama Cosmology Telescope, or some future eye on the universe, it may not only rewrite the history of the cosmos but challenge the very way we understand reality itself. We are living at a time when the universe is speaking to us more clearly than ever. And if we listen closely, we might glimpse the chapters that came before, the forces that shaped everything we know, and the infinite possibilities that lie ahead.